Here we have the infinite series with the expression n over n plus 2 factorial, and I'm going to use the ratio test to show that this series converges, and then also show that the series converges to 3 minus e. So let a sub n be the expression n over n plus 2 factorial. And so a sub n plus 1 be n plus 1 dividing by n plus 3 factorial. The ratio of a sub n plus 1 and a sub n, it will be n plus 1 over n plus 3 factorial dividing by n over n plus 2 factorial. And then n plus 3 factorial, it's the same as n plus 3 times n plus 2 factorial. And then the factor n plus 2 factorial and this factor n plus 2 factorial, they will cancel each other out. And then what's left up here is n plus 1. And then we have the n plus 3 times n. And then we get n squared plus 3n. The limit of the ratio a sub n plus 1 over a sub n is n approaches infinity. The limit of n plus 1 over n squared plus 3n is n approaches infinity. And then for this expression, let's divide everything by n squared. N dividing by n squared is 1 over n. 1 dividing by n squared is 1 over n squared. N squared dividing by n squared is 1. 3n dividing by n squared is 3 over n. As n approaches infinity, 1 over n approaches 0, 1 over n squared approaches 0, 3 over n approaches 0. And so we get 0, which is less than 1. And therefore, by the ratio test, the series with the expression n over n plus 2 factorial converges. And now let's show that the series, this infinite series here, converges to 3 minus e. And notice that n over n plus 2 factorial, we can rewrite this as n plus 2 minus 2. And then this is the same as n plus 2 dividing by n plus 2 factorial minus 2 over n plus 2 factorial. N plus 2 factorial is the same as n plus 2 times n plus 1 factorial. The factor n plus 2 here, and then this factor n plus 2, they will cancel each other out. And then what's left is 1 over n plus 1 factorial minus 2 over n plus 2 factorial. And so now we can rewrite the original series with n over n plus 2 factorial as the series with 1 over n plus 1 factorial minus 2 over n plus 2 factorial. When n is 1, we get 1 over 2 factorial minus 2 over 3 factorial. When n is 2, we get 1 over 3 factorial minus 2 over 4 factorial, and then plus 1 over 4 factorial minus 2 over 5 factorial, and so on. Here we get 1 over 2 factorial. This is minus 2 over 3 factorial plus 1 over 3 factorial. It will be minus 1 over 3 factorial. Minus 2 over 4 factorial plus 1 over 4 factorial is minus 1 over 4 factorial. And then the rest of it will be just minus 1 over 5 factorial, minus 1 over 6 factorial, and so on. Now we can rewrite this as 1 over 2 factorial and then minus this infinite sum here. And therefore the infinite series with the expression n over 2 over n plus 2 factorial is equal to 1/2 minus this sum right here. Infinite sum. Recall that the power series representation for e to the x is 1 plus x squared over 2 factorial plus x to the third over 3 factorial and so on. Let x be 1, then we get e to the first be 1, and then x is 1. We get 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial and so on. And the first part right here, 1 plus 1, and this is 1/2, is 5/2. And then the rest of it is this infinite series right here. And then subtract 5/2 from both sides. Then we get e minus 5/2 is this infinite series here. Earlier, a few moments ago, we got this result right here. The series n with the n over n plus 2 factorial is 1/2 minus 1 over 3 factorial plus 1 over 4 factorial and so on. But this infinite series here is e minus 5/2. So we have 1/2 minus e minus 5/2. 1 minus minus 5/2 is 3, and then minus e. And so in summary, the series with n over n plus 2 factorial is equal to 3 minus e, converges to 3 minus e. And that's the end of the video.